others right now, so I'm gonna kind of walk through some of the projects that we've done. And this one's gonna be our second assignment where we simulated X86lite. Um, so that was a super cool project where you kind of got a conceptual feel for the relationship between the actual instructions and what the machine's actually supposed to do. Um, so I guess there's no sense in getting into the weeds of all this, but we can kind of first talk about the machine that's actually doing the simulation. So we'll pull up the data types there. Um, there it is. So what our machine is a record where of three components. We got our flags, our registers, and memory. So our flags, as we can see here, are these three. FO is a flag for overflow, FS is a flag for the sign, and then FZ is a flag for zero. And fortunately enough, these three are sufficient to be able to decode a lot of the common Boolean operators. Not Boolean, like greater than, less than, or equal to, and so on and so forth, like comparison operators. And here we have our registers. That's exactly what you'd expect, as you see here. In this case, we implemented it as an array, but we have racks, RBP, RCX, and so on and so forth, all the way to R15, and then we also have RIP, our instruction pointer register. And then lastly, we have memory, which is just S bytes are just symbolic bytes, but again, it doesn't really matter as far as this high level overview is concerned. Here you can see their actual components, where this is a dummy byte because, or no, this is a dummy byte. This is a single byte that represents our instruction. Normally, the machine would use 8 bytes, or a collection of bytes. I guess it depends on the machine itself, but to actually spell out what the instruction is. But to make our lives easier, we just kept it in a single symbolic byte, and then padded the following 7 bytes with a dummy value, just to kind of pretend like it's actually taking up that much space. And then we have bytes, which are, bytes, a value, an 8-bit value. And then as far as the simulation goes, it was, relatively straightforward. There's a lot of helper functions and such, but we just kind of match against all of our possible cases and make sure that we update the flags, the registers, and memory correctly according to what the instruction is supposed to do. So, for example, in, I don't know, let's just do addition, I guess. What this is going to do is going to edit the flags, it's going to update the registers, and it shouldn't be able to, it shouldn't be handling memory because I believe x86 instructions, or at least like these binary operations, should only deal with registers. So like add, sub, and so on and so forth. So yeah, I guess it's kind of hard to kind of go more in depth than that to try to keep this video short. So I guess I'll just show all the test passing, and we'll call it a day.